Okay, so in this clip, we're gonna go over Wi-Fi data rate. Especially, we are looking at this standard of IEEE 802.11a. Okay, so this is one of the earlier Wi-Fi standards. It consists of 64 subcarrier, right? So each subcarrier has this much spacing, so bandwidth, which is 312.5 kilohertz. But out of the 64 subcarriers, only 52 subcarriers are used with a total bandwidth of 16.6 megahertz. The remaining space was used as guard band, right, between different channels. Even though subcarriers are supposed to be orthogonal in OFDM, but in actual implementations, it's not perfect, right? So we have to leave some space for some bandwidth for guard band. Okay, and out of these 52 subcarriers, only 48 are used for data transmissions, and 4 are used for pilot subcarriers. Okay, now in this 802.11a, uh, they use different kind of modulation, starting with the lowest order, which is BPSK, up to 64 QAM. Okay, and they use actually two different code rates, either 1/2 or 3/4. Okay, and the data rates start from 6 megabit per second, and the maximum is 54 megabit per second. So for today's standard, this is relatively low, but this is back in starting in 2000. Uh, so if you look at how we obtain this 6 megabit per second, so 54 megabit per second, and something in between, where does those data rates come from? Okay, so let's start with the number of subcarriers. Even though there are 64, only 48 are used for data. 12 are used for guard band, and 4 are pilots. So pilots subcarrier are used for channel estimations. OFDM symbol period for 802.11a is 4 microseconds, right? So 3.2 is for data, actual data, and 0 0.8 microseconds, that's for cyclic prefix, which will be used to deal with in the symbol interference. Okay. Now there's one option here which is for microseconds. In some other later standards, there might be different choices for symbol period. The shorter the symbol period is, the higher the data rate will be. So let's look at the lowest uh, rate, which is 6 megabit per second data rate. Where does that come from? Okay, so remember we have this 48 data subcarrier. Each one will carry different data stream. Okay, and we'll use the lowest code rate, which is 1/2, right? Or 1/2. What does that mean? So that means one data bits, and we need the output from the encoder will be 2 coded bits. So that means uh, 50% will be for data, and then 50% will be redundant, which will be used for error corrections or error detections, right? And that's the purpose of um, of coding or encoding, or channel coding rather. And we'll use the lowest order of modulation, which is BPSK. That means one symbol will represent or will convey only one coded bit. Okay? And then one symbol will use 4 microseconds to transmit. Okay, so if you multiply everything together, so 48 data subcarriers, each one will use 1/2 code rate. That means one data bit per 2 coded bit. And then one coded bit will be represented by one BPSK symbol. Okay, and then one symbol will use 4 microseconds. Okay, and if you look at it in this way, you see that coded bits it's cancel with coded bits, symbol cancel with symbol, and at the end we have 48 multiplied with 1/2 multiplied with 1, and then divided by 4 microseconds. So we get 6 millions bit per second, or 6 megabit per second at the end. Okay. Now let's look at the maximum data rate that IEEE 802.11a provide. Again, right, we have 48 subcarriers for data. Now, in terms of code rate, we use something that is more efficient. So instead of 1/2, we use 3/4, and that's the maximum code rate that is allowed for this standard. So that means 3 data bits, uh, and we use they're going to be 4 coded bits. So that means there's 1 bit for redundancies, or 25% will be used for error corrections or error detections. Okay, and 75% will be data. Okay, and then we use for modulation, we use the highest order that is allowed, that is 64 QAM. That means one symbol can represent up to 6 coded bits. Okay, so 64 is 2 to the power of 6. So that's why one symbol are able to represent 6 bits. And again, the symbol period is 4 microseconds. There's no choice here. There's only one option for this standard. Okay? So if you multiply all the numbers out, you get 48 multiplied with 3/4, multiplied with 6, multiplied with 1/4. It's going to be, the unit is going to be megabit per second, so 54 megabit per second. Okay. Now, in later Wi-Fi standards, there are multiple input, multiple output technique that is used. So remember, this is where you have multiple transmit antenna, multiple receive antennas. So the device, our device have multiple antennas nowadays, and the router or the Wi-Fi access point can be equipped with more than one antennas. So for example, if we have 2x2 configurations, that means 2 uh, uh, antennas for the transmitter and 2 antennas for the receiver, we can send up to 2 data stream in this scenario. If we have 4x4 configurations, then we can send up to 4 data stream. Okay, so if we use 4x4 configurations, then that means we can transmit 4 data stream simultaneously using that MIMO scheme. And let's say we use 3/4 code rate and 64 QAM modulations. The data rate will be increased, right? So 48 is the same, and then 3/4 is the same, 6 is the same, 1/4 microsecond is the same. But now we have this 4 times uh, in addition to all the rest of the numbers. So this is represents the number of data streams from MIMO configurations. So instead of 54 megabit per second, we increase the rate by 4 folds. It's become 216 megabit per second, for example. And that's conclude our video on Wi-Fi data rate.